Hello friends, welcome to the session on power supplies. In this session, we'll be discussing about half wave rectifier. In this session, we will see what is the block diagram of power supply. We will see what are the different types of rectifier circuits that are used in power supply. We will see what is the circuit diagram of half wave rectifier. We will see the working and analysis of the half wave rectifier. Friends, as you know that you are viewing this session on my YouTube channel, and you can always subscribe to the channel so that you can watch many other educational videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question what we mean by power supply. You will find that whenever you want to operate any electronic device, then in order to get it operated, you will need a power supply. That is, without any power supply, no electronic device will get operated. So power supply, you can say, is an electronic circuit or electrical device that will supply the required electric power to the load, such as the instrument or the device. So whenever we make the use of electronic devices such as computer system, mobile phone, or radio receiver, or television system, then all such electronic device will require the power supply, and without power supply, no such device will work. So the main purpose of the power supply is to convert the input electric current into the suitable form that is being required by the device, because every device will have a different form of requirement and the input may be a different. Say for example, in India, the input AC that is being available to us is 230 volt AC, and while most of the electronic devices will require a DC power supply, and therefore it is necessary to convert the input AC 230 volt AC into the appropriate form of low voltage DC, and this can be achieved by making the use of the power supply. So the main purpose of the power supply is to convert the electric current from a source to the current voltage and the required frequency that is being required by the load. So most of the time, the devices will require the DC source or the DC power supply, and therefore the input AC power need to be converted into the DC. So AC, that will stand for alternating current, and DC, that will stand for direct current. So when the source current flows in both the directions, in positive and negative, then it is called as alternating current. And when the current flows in only one direction, then that is being called as a DC or direct current. So whenever we think of any DC regulated power supply, then it will consist of these blocks. The first block will be transformer. So transformer will convert the input AC into the low voltage AC. So transformer can be either a step up transformer or it can be a step down transformer. So step down transformer are mostly required in the power supply, where the high voltage input AC is being converted into a low voltage AC. The output of the transformer is being connected to the rectifier circuit, where it will convert the AC into DC. The filter circuit will provide stabilization to the output, and the regulator circuit will develop the regulated DC output. So these are the four main blocks that are normally used in any construction of the regulated power supply. Out of which, as far as this session is concerned, we are going to discuss only one rectifier circuit, and this rectifier circuit is being called as a half wave rectifier circuit. Rectifier circuit, you can say, is an electrical device that will convert the alternating current or AC, which will periodically reverse the direction. So sometimes it is positive, sometimes it is negative, and it will convert it into a direct current. So the direct current is a current which will flow only in one direction. So the device which will convert AC into DC is being called as a rectifier. So basically, there are three types of rectifier: half wave rectifier, full wave rectifier, and the bridge rectifier. Full wave rectifier and bridge rectifier both are of the type full wave, but their working or their component or their circuit diagram is different. Half-wave rectifier, as its name indicates, it will convert only half cycle of the input AC into DC. And that is the reason it is being called as a half-wave rectifier. So half-wave rectifier will convert the AC signal to the DC by passing either the negative half cycle or the positive half cycle of the waveform. So only half cycle is being used, and therefore one can easily say that the efficiency of this circuit is much less than that of the full wave rectifier circuit. But this circuit is the simplest type of circuit, and this circuit will require only one diode for its construction. So if you are having less number of components with you, or if you want to construct a simple DC power supply, in that case, you can always go for the half-wave rectifier circuit. So this is the circuit diagram for half-wave rectifier circuit, which will initially consist of a transformer. This transformer is a step-down transformer, to the primary of which we have applied a 230 volt AC. At the secondary, we will get the 6 volt AC voltage. So transformer will not convert AC into DC, but transformer will either step up or step down the input AC. So in this case, it is stepping down, that is input is 230 volt DC, while the output is 6 volt AC. This voltage is being connected to a diode, where the diode will have two terminals, anode and cathode. So anode is being indicated by this symbol and cathode is indicated by this symbol. And the output of the diode is connected to the load resistance such as resistance R. Now, when the terminal S1 of the transformer secondary is positive with respect to the terminal S2, then the anode is positive with respect to the cathode, and therefore current will flow through the diode. When the diode is forward biased, then the current will flow through the diode, and the current will flow through the resistance R. And therefore, across the resistance R, the positive half cycle is being developed. Now, in the negative half cycle of the input AC, S1 is negative with respect to S2, and therefore anode is at negative voltage than that of cathode. And therefore, this diode will remain in off condition, or it will be reverse biased. And in that case, no current will flow through the diode, and therefore the current will not flow through the resistance R. That is, we will observe that when the full AC input cycle is applied to this circuit, then the current will flow only in one direction. For one cycle, only one half cycle is produced at the output. And therefore, current is flowing in only one direction through the resistance R. And therefore, we will say that this is a DC current, and the voltage developed across this resistance R is a DC voltage. It is possible that you can obtain the average DC output in case of half-wave rectifier. The expression for the output voltage can be written as VOT is equal to Vm sine of omega t, when the value of t is in the range of 0 to t by 2. And the output will be equal to 0 when the value of t is in the range of t by 2 to t. So in that case, we can develop the expression for the output DC voltage or average DC output voltage. VDC is equal to 1 by t integration of 0 to t VOT into dt. So if I substitute this t, if I make the part of this t into 2, 0 to t by 2 and t by 2 to t, then you will find that this will be equal to 0, and this VOT can be replaced by Vm sine of omega t into dt. Now, Vm can be taken out because Vm is the maximum voltage, and that can be taken out of the integration. So in the integration, we will have sine of omega t. If we take the integration, it will be minus cos of omega t divided by omega, and the range will be from 0 to t by 2. So if we substitute the value, then we will get the expression Vm divided by omega t minus cos of omega t by 2 plus cos of 0. Cos of 0 is 1, and if you substitute omega is equal to 2 pi by t, then you will find that this minus minus will become plus, and therefore we will get the expression Vm divided by pi. So this is the average DC output for the half-wave rectifier. It is also possible that you can obtain the expression for root mean square value or RMS value of the half-wave rectifier, which can be obtained by using this expression V square RMS is equal to 1 by t 0 to 2 V square VO square t into dt. So again, if I divide it into two parts, this integration 0 to t by 2 and t by 2 to t, then the value of this output is 0, and here we will get sine square omega t dt. Now, if I divide it by 2, then I have to multiply it by 2 so that the value remain unchanged, and I will get in the bracket 2 sine square omega t dt. So it can be written as 1 minus cos of 2 omega t into dt. If I divide it, then you will find that it will be dt minus Vm square by t integration from 0 to t by 2 cos of twice omega t into dt. So if I integrate dt, then I will get t. And if I integrate this term, then I will get sine of twice omega t divided by twice omega. So if I substitute the values, then I will get the expression Vm square divided by 4 minus Vm square divided by omega t into sine of twice omega t minus sine of 0. So this is just nothing but Vm square divided by 4. And therefore, in case of half wave rectifier, the root mean square value or the RMS value can be given as Vm divided by 2. So thank you, friends, for viewing the session. Hopefully you have understood what we mean by half wave rectifier and how exactly this half wave rectifier works. Thank you all.